Hi friends, I welcome you all to the Static GK 2025 channel, and today we'll be dealing with the topic physical quantities, units and dimension, which is a physics module. So let's start. So the SI unit of current is ampere, and 1 ampere is equal to 6.25 into 10 to the power of 18 electrons per second. What is this? See, consider there is a point in space, and through that point, 6.25 into 10 to the power of 18 electrons, this much amount of electrons, if it is able to pass through that point in 1 second, it is considered as 1 ampere, right? Next, the SI unit of specific resistance is ohm meter. If they ask generally what is the unit of resistance, it is ohms, right? Remember it. Next, force. SI unit of force is Newton, and its dimensional term is MLT minus 2. Obviously, mass into acceleration, mass is m kg, and acceleration is meter per second square, which is LT minus 2. So that is how we got this formula. Next, SI unit of energy is kilowatt hour, or we could say it is calorie, or we could say joule. This is very important question. Energy can be in kilowatt hours, it can be in calories, or it can be in joules. Generally, this kilowatt hour where we use in domestic tariffs, the electric bills that we used to pay, in that kilowatt hour is the quantity that we choose. So this domestic tariff we choose in kilowatt hours, and this is the electrical energy, right? And how much in joules per hour it considers. So it is equal to 3600 kilojoules per hour, or 3.6 million joules per hour. Very important. So this is very important with respect to SSC. They have asked 3 to 4 questions in the preceding 2-3 years from this. So energy, kilowatt hour, calorie or joules, and kilowatt hour is equal to 3600 kilojoules per hour, and which is 3.6 million joules per hour. So next, so the SI unit of distance, like parsec, light year, kilometers, meters. So what is this parsec, light year, kilometers, meter? See, generally, distance will measure in meters and kilometers. The longest, like the highest values of distance that we measure is through the light year. Light year is basically the distance light travels in 1 year. Like 365, 1 earth year, which is 365 days, how much distance light can travel, that is considered as light year. And above light year there is a distance which is greater than the light year, that is parsec. That parsec is actually is equal to 3.26 light years. Parsec is 3.26 light years. So this is the highest value of distance measurement that we use. Then comes light year, and as I said, light year, the distance light travels in 1 year. Earth year, 365 days. And the general data we have to remember here is 8.311 minutes. What is this 8.311 minutes? This is actually the distance light takes to reach from sun to earth. It takes 8.311 minutes, right? Let's go to the next, this luminous intensity. The SI unit of luminous intensity is candela. And 1 candela is equal to joules per second or watt. 1 candela is equal to joules per second or watt. Next topic, brightness, which is luminescence. See, actually I placed this in a scientific arrangement. See, first we'll read about luminous intensity, which is candela, and then related to it, brightness, luminescence, right? So this nits is a term you would generally hear with respect to smartphones. Whenever a new smartphone is launched, they say that the peak brightness in nits 800 nits, 500 nits for this particular phone. So that is actually the brightness, luminescence, and the SI unit of it is 1 candela per meter square. Actually, in phone, what we are seeing, there is an area, and in that area, how much luminous intensity is coming. So remember it like that. Brightness, luminescence is equal to nits, and 1 nit is equal to 1 candela per meter square. Next is density. For density, the SI unit is kilogram per cubic meter, kg meter cube, right? Let's come to this part of the SI unit, pressure. So pressure, generally we know the SI units are atmosphere. So the SI unit of pressure is atmosphere, bar or Pascal, right? This is very pretty much simple, and like in various contexts, we use pascals, atmosphere, or bar, right? So the next is the SI unit of work done is joules. SI unit of voltage is volts. Very simple. This is very important. Capacitance, conductance. SI unit of capacitance is farad. SI unit of capacitance is farad. And SI unit of conductance is Siemens. SI unit of conductance is Siemens. So here I have a trick. See, for example, there is a fan. In your fan, you have the capacitor. So you remember farad changed the capacitor of your fan. So farad capacitance. Then the next thing that to remember conductance is, for example, there is a person called Siemens, and while he was trying to do some work with the electrical switch, he got conducted with electricity. So conductance Siemens, you can remember like that. Basically, this is my trick. If you want to add on your tricks, it's highly appreciable. So next, let's go to the magnetic field. The SI unit of magnetic field is Tesla. Tesla, Elon Musk, remember like that. He has a magnetic field, he attracts the persons. So you could remember that in that way. So now see, I have arranged magnetic in one go. So we have magnetic field and magnetic intensity. Magnetic intensity, the SI unit is Oersted. This Oersted is represented in OE, and one Oersted is actually equal to 1 dyne per Maxwell. Don't get more depth into this topic. See, 1 dyne per Maxwell, it is given in the CGS system. Like we have a SI unit, kg, meter, seconds, we use that. Actually, this is representation in the CGS system, another system. Like, so in that, magnetic intensity is represented as 1 Oersted, right? So just remember it. And magnetic flux, when we come to the magnetic flux, we represent it in SI unit Weber, and for the magnetic flux density we use the term Gauss, right? So again, let's have a small recollection. For pressure, we have atmosphere, bar or Pascal as the SI unit. For work done, we have joule. For voltage, we have volt. For capacitance, we have farad. For conductance, we have Siemens. For magnetic field, we have Tesla. For magnetic intensity, we have Oersted, and for magnetic flux, we have Weber. For magnetic flux density, we have Gauss. Let's move on. Basically, in this vector quantity, what is a vector? Vector is a thing which has a magnitude and also has a direction. So those things which has magnitude and is not defined by directions, they are called a scalar quantity. Right? So examples of vector quantities like acceleration, it has a direction towards where you are moving. Similarly, force, where you are applying that force. Momentum in a particular direction is there. Velocity, it has a direction. So weight, it has a direction. So mostly all the things that we study, it has magnitude, but whether it has direction or not, only when it has direction, it is known as the vector quantities. So next is the same dimension. This is also one of the PYQ that they have asked. Like they have equal work and energy. They both have the same dimension, which is ml square t minus 2. Almost 3 to 4 times they have repeated this in the SSC examination. So keep this in your mind. Basically, what I say to the students is that don't get more depth in the topic. See, instead, you just have a glance of this, and this will help you in examination. More than this, they will not ask. Just have a basic idea of that, and this will help you. The question, 1 or 2 questions that if you get, it will be easy for you to crack. Next, at last, thanks for seeing this video, and if you like this video, please do subscribe and please share it with your friends. Thank you. We'll see you in the next video.